I think the essential thing to do with any integral before you start launching into integration by parts or substitution or whatever is to just see whether it can be simplified by very simple algebraic methods. And this example shows you just that. Let's have a go. So we've got that integral in t, we've got a limits, and we need to show that a is equal to ln k. Okay, we've got to do the integral first. If you split this integral, it turns into two very easy integrals. It turns into the integral from a to 2a of t over t dt plus the integral from a to 2a of 1 over t, also with respect to t. T over t in this integral will simply be 1. So let's now just integrate. The integral of 1 with respect to t is simply t. And our limits are a to 2a plus. Now the integral of 1 over t is ln t, also from a to 2a. Remember, t was the integral originally we couldn't do because this is equal to t to the minus 1. And if you raise that power by 1, you get t to the naught, which is 1, which is clearly the wrong answer. So that would be the wrong way to do that particular integral. If you don't remember that the integration of 1 over t is in fact ln t, then you need to look back at a previous example that I've done which involves that proof. Okay, now because we've got limits which are stated, we don't have to bother with c, because the c's would effectively cancel out. So I won't be writing c in any of this, but just be aware if you didn't have limits, c would come into this problem. Okay, let's now put the limits in. We get that our integral is equal to, first putting in 2a and then a, we get 2a minus a for the first part. And putting in first 2a and a, well, let's just write it out, we get ln. So this is equal to a plus. Now, by one of the laws of logs, where you've got two subtracted logs, we can state that as a single log of 2a divided by a. So this becomes ln 2a over a. Again, simplifying, the a's cancel here. We get this is equal to a plus ln 2. And that's the answer to the integral. Now we've got to use the fact that the integration that we've now performed is equal to ln 7. So we can just write that down. So we get a plus ln 2 is equal to ln 7. So subtracting ln 2 from both sides, we get a is equal to ln 7 minus ln 2. And again, by that same rule of logs, where you have two separate logs which are subtracted, this can turn into a single log of the fraction of 7 over 2. We get that a is equal to ln 7 over 2. So if we now compare this with a is equal to ln k, as stated in the question, I can say that therefore k is equal to 7 over 2. And that is your answer.